All right, we're looking at geometric proofs. We looked at algebraic proofs yesterday, but today we're going to look at geometric proofs. So, looking at our notes, we have a proof that we're going to plan and work out here and write. We have the given here, and it says if two angles form a linear pair, then they are supplementary. Well, we're going to write a proof to prove that statement, and we have a given that MJK, this angle right here, is a linear pair with MJL. So these two form a linear pair. We're going to prove that those two angles are also supplementary. So when developing a plan for our proof, it's given that these two are a linear pair of angles. JL and JK are opposite rays, so they form a straight line. We're going to explain why the measure of the two angles must equal 180. Well, first of all, the one thing we're going to have to do, we're going to have to be using the angle addition postulate. That if we were to add these two angles, then they would be equal to the larger angle, or the straight angle. We're also going to have to prove that the measure of angle MJK plus the measure of angle MJL is equal to the measure of angle LJK. So that's kind of the plan that we would have when coming up with this, because we're going to have to prove that they are supplementary. We're going to have to, and on top of that, didn't mention that, but the measure of angle LJK is going to have to equal 180 degrees because it's a linear pair. So looking at the notes, here we have the proof right here. We're going to write this proof and fill in the blanks with the missing reasons. Well, the first reason we know is always going to be the given. That was given to us at the very beginning, so we can cross that option out. Then we have JL and JK are opposite rays. They're opposite rays because that's the definition of a linear pair. Now we have JL and JK form a straight line. That is the definition of opposite rays. If we didn't know anything here, definitely that's not angle addition postulate, and that's definitely not substitution, so it would have to be the definition of opposite rays. Well, the measure of LJK, the straight angle, is 180 degrees. That's the definition of a straight angle. Straight angle is 180 degrees. So then we have the two angles added up, the two smaller angles equal the straight angle. And that's the angle addition postulate that's in your notes from yesterday's assignment, where we add the smaller angles to equal the one larger angle that contains them. Now notice that number 6, we have the same equation, except instead of the measure of LJK, we put 180. We can do that because we showed that that LJK was equal to 180. So we've used substitution to write that new angle. The two are supplementary because the definition of supplementary angle says that if you add them up, if their sum is 180 degrees, then they're supplementary. So there is our proof for linear pairs. So from now on, when we can use the linear pair theorem so that if we have a linear pair, we can automatically go straight to here and say they are supplementary. So we can use that linear pair theorem in other proofs, and we will on the very next proof we have. Now this question, if two angles are supplementary, must they be a linear pair? The answer to that is no. Yes, these are a linear pair, these two angles. But what if I have an angle like this, and it's 120 degrees, and then I have another angle over here that's 60 degrees? Well, they add up to 180, therefore they're supplementary. Now, they're not a linear pair, which is why our answer to that question is no. Okay, right here, we're going to use the linear pair theorem that we just proved to prove a result about vertical angles. We are given that these two angles are vertical angles, VXW and ZXY. We're going to prove that the measures are the same. Now we know they are, but again, a proof is to explain how we know they are with proof. First reason, right off the bat, we don't have anything to choose from. We're having to come up with this, but it's a given. That was given to me. VXW and ZXY are vertical angles. That was given right here. So then we have that VXW and ZXY are formed by intersecting lines. Well, that's the definition of vertical angles. Vertical angles are formed by intersecting lines. Number 3 statement, they're a linear pair. Well, the definition of a linear pair says two adjacent angles that form a straight angle, which those two angles do. VXW and WXZ, and then we also have WXZ and ZXY. So we have two pairs of linear pairs. Now it says that VXW and WXZ are supplementary. Well, that is what we just proved in the previous proof. If we have a linear pair, they're supplementary. And that was the linear pair theorem. If they're a linear pair, they're supplementary. Now, their sum, if they're supplementary, is going to equal 180 degrees. That can be proven with the definition of supplementary angles. Now notice the next one says linear pair theorem as our reason. What are we going to say? Well, we have two things that are linear pairs. Therefore, we're going to have two things that are supplementary. So not only are VXW and WXZ supplementary, but angle WXZ and angle ZXY are also supplementary. And that would be, again, same thing, linear pair theorem. If they're a linear pair, then they're supplementary. And if they're supplementary, then their sum is 180 degrees using the definition of supplementary angles. Now, notice these two were both equal to 180. Therefore, if they're both equal to 180, they're both equal to each other using the transitive property. Remember that if A equals B and B equals C, then A equals C. So then once we do that, we end up with this next step, step 9. And you'll see that if they subtracted WXZ from both of those sides, we're left with VXW and ZXY. And that would be the subtraction property of equality. Okay, so now we've proven that if they're vertical angles, they're congruent. Let's look at the next proof. This proof says that three and 5 are congruent. Their measures are equal. 3 and 5. Prove that P and Q are parallel. So let's go through our steps to see that, show that. So 3 is congruent to 5. That's a given. 5 and 6 are a linear pair. We see that. 5 and 6 right there form. When you add them up, that's the definition of a linear pair. Two angles who share a common side and opposite rays form a straight line. Now remember, if they're a linear pair, because of the linear pair theorem, then angle 5 and angle 6 are supplementary. And if they're supplementary, then their sum is 180, which again is the definition of supplementary angles. Now look at what happened from 4 to 5. It's the same thing, except for instead of the measure of angle 5, we have the measure of angle 3. Well, we can substitute that because of what was given to us in the first statement. 3 is equal to 5, so we can substitute that. So we use substitution. And then if their sum is 180, then we can say that they are supplementary because of the definition of supplementary angles. And since 3 and 6 are supplementary, P and Q must be parallel because consecutive interior angles converse. If consecutive angles, interior angles are supplementary, then the lines are parallel. All right, we have a few more on our notes to look at on these proofs. Again, we're going to, given that FA is congruent to LT, that's given. So for our given statement, FA equals LT. And what we have next, we're going to prove that FL is congruent to AT. That's what we're trying to prove. Now, here we have FL plus LA. FL plus LA equals FA. And the same thing for LA plus AT equals LT. That is the segment addition postulate. Now if you look at number 3, we have FL plus LA equals LA. Well, these two are equal to each other. How can we go there? Well, if FA, it's really kind of double substitution, but it is substitution. FA and LT are equal to each other, so if they're equal to each other, then these two must also be equal to each other. Again, that was substitution. And now I can subtract LA from both sides, leaving me with FL equals AT, which is what I was setting out to prove. And the reason we can do that is because of subtraction. All right, look at the next proof. What we're trying to do here, B is midpoint of AC. So B is the midpoint. So I'm going to write that as my statement. B is the midpoint of AC, and the reason is because it's given. Now they're saying that AB is congruent to BC. Well, how do we know that? Because if B is the midpoint, then it splits it up into two equal segments. And that would be the definition of midpoint. Now, we also have a segment addition postulate. And again, well, I didn't mention this, but what are we trying to prove? We're trying to prove that AB plus CD equals BD. Okay, so BD, this segment right here, is what we're trying to what we're going to look at. And we're seeing segment addition postulates, so we're going to add two angles to equal one larger angle. Well, we already have this right here, so we're going to look at segment BD. So BC plus CD equals BD. Now notice, remember what we said in statement 2. AB and BC are equal to each other, so I can replace BC with AB. So AB plus CD equals BD, and I can do that with substitution. And again, that is what I was trying to prove right there. All right, last one in our notes. First reason, always going to be what? Given. Now if it bisects, it splits it into two equal angles. We're talking about the angles here. So BAC is congruent to CAD, and likewise CAD is congruent to DAE. Because these two angles have been bisected, that is the definition of angle bisector. And it's going to be the same for both. Because CAD is congruent to DAE because ray AD bisected it, so we have two congruent angles. That's all because of the definition of the angle bisector. So now we're trying to prove that BAC is equal to DAE. We're talking about BAC and DAE. Those are congruent because this is, notice I have A equals B, B equals C, therefore A is equal to C, which is what our proof statement was. And that's the transitive property. Okay, looking at this homework assignment, I'll try and give you some hints on this one. I'll kind of write the reasons maybe out of order. Well, actually, let's work on I'll go ahead and work on this one with you. We have this as my given statement. See that up here? That's part of this given statement. So, of course, we're going to be given first. AB is congruent. So that says B is the midpoint of AC. Well, that means that this segment is congruent to this segment. That's what we're saying here. And the same with DE and EF. Those are congruent. Because that's the definition of midpoint. If we have a midpoint, then the two segments are congruent. Midpoint is what that's abbreviated for. Now this one's be careful because we went from congruent to equal. Remember, they're different. Congruent means same shape. Equal has same measure. Well, if segments are congruent, then they also have the same measure. And that is the definition of congruent segments. Now I have AB plus BC equals AC, DE plus EF equals DEF, or DF. The two smaller segments equal the long segment. That is the segment addition postulate. And now what we've done, I really don't like that it's written this way. I would much prefer it to be AB plus AB equals AC, because it's the same as this, only we substituted BC with AB since they were equal to each other. So that would be substitution. I didn't do the other one, but this one basically is the same thing. Now I have AB equals EF, where did that come from? That one's kind of a tricky one because it was also given. So the reason we have that, it was given. Now, what did I do to AB and EF? I multiplied by 2, which means I used the multiplication property. And it's going to end up with this right here. 2AB is equal to AC, so we substituted 2AB with AC, 8. And then 2EF is DF, so we're going to substitute 2EF with DF. So that was substitution. And then again, if their measures are equal, then they're also congruent. Definition of congruent segments. Okay, let's look at the next one on your homework assignment. We have HKJ is a straight angle. We have ray KI bisects that angle. Means it splits it up into two congruent angles. Now we're going to prove that IKJ is a right angle. So what was given? Given was angle HKJ is a straight angle. That was given. Well, the measure of HKJ is 180. That's going to be the definition of straight angle. If it's a straight angle, its measure is 180. Now what else was given? That right there, wasn't it? So ray KI bisects angle HKJ. Well, if that's the case, then these two angles are congruent because of the definition of angle bisector. Their measures are equal because of the measures of definition of congruent angles, just like the segments, angles have one, same thing. Now we're using the addition postulate, which means angle, the measure of angle IKJ plus the measure of angle IKH equals the measure of angle HKJ. Well, they again wrote it 2 times IKJ, but remember, IKJ is congruent to IKH. So basically we could write IKJ plus IKJ, since we already said they were congruent right here, which is why they multiplied 2 times IKJ. And that equals 180 degrees because all we did was we substituted. We substituted HKJ with 2 times IKJ. Now the measure of IKJ is 90 because of the division property of equality. We divided both sides by 2. And then we said IKJ is a right angle because the definition of right angle says if it's 90 degrees, it's a right angle. That's it on this page. Continuing to look at this, of course the first reason is given. QS equals SP. I'll just go ahead and jot a few of these answers. You can check these. If you don't want to see the answers, want to try it on your own, come back. But I will fill the homework in if you really want to check your work. No explanation. I'm just going to fill them in. if you can read my writing.
Nico, when are we getting out of rows?
Never.
Never. It's not what I wanted to hear. Huh? That's when we were getting out of rows. Never. That's what he said.